Namaste friends, welcome to the third part of the number system series. In the last lesson we talked about the binary number system. In this lesson we shall see how to convert a decimal number to binary. We often need to convert numbers from one number system to another. Although we will be dealing with both decimal and binary number systems, the mathematical steps we perform will always be in decimal. Normally, whenever we don't specify a base explicitly, we always assume it to be base 10, that is decimal. For binary numbers, we will almost always specify the base explicitly to avoid confusion. Now, before we start with decimal to binary conversion, we will just try to recap our understanding of division. So, divisor. It is a number by which another number is to be divided. Dividend is a number to be divided by another number. Quotient is the result obtained by dividing one quantity by another. Remainder is the number which is left over in a division in which one quantity does not exactly divide another. Okay, let's take an example. So let's say we divide 23 by 3. What do we get? We get 7 with a remainder of 2. So in this example, 23 is the dividend, 3 is the divisor, 7 is the quotient, and the remainder is 2. Note that when dealing with remainders, we will express quantities as whole numbers and not fractions. So if we were to express the same division in fractional or decimal form, we would get 23 divided by 7 as 7 and 2 by 3 in the fractional form and 7.666 recurring in the decimal form. So let's take a few more examples of division. So when we divide 7 by 10, we get the quotient as 0. Now it is important to understand why we say the quotient is 0. It's 0 because the dividend is smaller than the divisor. 10 cannot divide 7, and the remainder we get is same as the dividend, that is 7. We can write this division in the fractional form as 7 by 10 and the decimal form as 0.7. Similarly, 1 by 2 gives us a quotient of 0 with a remainder of 1. The fractional form is 1 by 2 and the decimal form is 0.5. When we divide 11 by 10, we get a quotient of 1 with a remainder of 1. The same result can be expressed in fractional form as 1 and 1 by 10 and in the decimal form as 1.1. 3 divided by 11 gives us a quotient of 0 with a remainder of 3. The fractional form is 3 by 11 and the decimal form is 0.27. 40 divided by 5 gives us a quotient of 8 and a remainder of 0. Notice how 5 perfectly divides 40, so the remainder is 0. Whenever the remainder is 0, the fractional form, the decimal form, is same as the quotient. Division by 2. The largest remainder that you can get by using any divisor d is d minus 1. So when the divisor is 2, the only two possible remainders are 0 and 1. Remember, in the binary number system, we have only two possible digits, 0 and 1. So this concept is very good to remember for decimal to binary number system. Remember, whenever you divide a number by a divisor d, the largest possible remainder you can get is d minus 1. Again, when we divide any number by 2, the largest possible remainder we can get is 1. Now, let us take a look at an example. We will take a number 13, which is in the base 10, and convert it into the binary form. So, what do? Remember, when we divide a number by 2, the largest possible remainder we can get is 1. So, we divide 13 by 2. We get the quotient as 6 and the remainder as 1. Now we continue the operation until we get the quotient as 0. So we again divide 6 by 2, which gives us a quotient of 3 and a remainder of 0. Again, we need to divide 3 by 2. 2 goes into 3 once and gives us a remainder of 1. Again, we divide 1 by 2. So 2 goes into 1 0 times and gives us a remainder of 1. So now we get the quotient as 0 and the remainder as 1. So as soon as we get the quotient of 0, we stop the process. And now all we need to do is collect the remainders from bottom to top, which gives us the result as 1101 in binary. Notice that the rightmost bit is also known as the least significant bit, or LSB, and the leftmost bit is also known as the most significant bit, or MSB. Let us take a look at another example. This time we will convert the number 20 from base 10 to base 2. The usual process: we start dividing by 2. We get 10 as the quotient, 0 as the remainder. We go on, we get 5 and 0, 2 and 1, 1 and 0, 0 and 1. Notice now the quotient is 0, so we stop the division. We collect the remainders from bottom to top, and we write the number as 10100. So 20 in decimal is 10100 to the base 2. It is good to remember that whenever you have an even number, the least significant bit will always be 0, and whenever you have an odd number, the least significant bit will always be 1. So in the previous example, when we converted 13 to binary, the least significant bit was 1. That's it for this lesson, friends. See you in the next lesson.